So in the architecture, we're going to have a Matter device such as a smart lock. And these are normally controlled with a Matter controller such as a smart home hub. And in this particular video series, we're going to do it slightly differently. We are going to use a MCP server to control our Matter smart home devices. So the MCP server stands for Model Context Protocol, and this will allow AI agents to speak with our Matter devices. But the Matter devices require a protocol called the Matter protocol. And we're going to use some utility classes to help the MCP server communicate with our Matter devices. So first of all, we're going to use the Python Matter server, which is a utility class provided by the Open Home Foundation. And we're also going to experiment with the chip tool, which is provided by the Connectivity Standards Alliance in the chip repo. So if we don't have actual Matter devices, that's okay. We're going to use a Matter virtual device, which is provided by Google. And I'll show you how to set this all up as well. So the first place we're going to start is setting up the Matter virtual device. So if you go to the link on the developer home.google.com, you'll see the link to the Matter virtual device. And this is a virtual device for developing and testing Matter-based devices. And it's useful if you don't have any Matter devices yourself, because we can set one up on our laptop here. So it has a number of devices that it's supported. So these are all the latest devices that are supported in the Matter protocol. And we're going to focus on the door lock in particular. So the instructions are on this web page about how to install it. I'm just going to go through it now. So depending on whether you're using Linux or Mac OS, there's different instructions. So we're just going to copy the link here for the Linux one, and that's the Mac OS one. So we're just going to copy the link for the Linux one. We're going to go over to our Linux terminal, and first of all, what we're going to do is we are going to download our we're going to go into our folder, and we're going to download our Debian package. And then what we're going to do is we are going to use the installation to go and install that, and that's in this command here. So the dpkg command. So we're just going to paste it in. Now I've already done this one, I won't run this again, but once you do this, this will install this. So then what we can do is we can then go and run the Matter virtual device, just typing mvd. I'm going to run that in the background. And this is going to open up the Matter virtual device. And I already had a Matter virtual device, so I'm going to show you what it's like if I delete that one and start from fresh. So again, if we go, and this is important, you can remove, if you're running previous Matter virtual devices, it's good practice to remove any configuration from before, and I found this helps in testing. So just go and remove everything in the .mvd folder in your home directory. So remove and just go into your home directory and .mvd and remove everything there. So then what we're going to do is we're going to start our Matter virtual device. And here we have a number of device types we can select. So you can scroll down here, you can have an on-off light, and you can give it a device name, and you can give it a discriminator code which is needed, and we have a port that's used, and the vendor ID and product ID are important. We'll leave them set as they are. So in this particular video series, we're going to go and create a virtual door lock, and we're going to call this, just like in the movie, we're going to call it the Pod Bay Door Lock. So just going to type this in here. Okay, just go and create the device now, and you'll see a lot of logs happening in the background there, and you'll see here that it has a number of states, and at the bottom we can actually control the states, and you can see at the bottom there it says the device is not commissioned. So that's important to realize that it needs to be commissioned onto a Matter network. So we can control the states of it there, and if we look at the device details, we have the name of the device type, discriminator, vendor ID, and all the things we needed. And then we have the device logs, but you're seeing it on the console as well. So everything that's happening, we can check the logs here as well. If you look on the bottom here, it says device not commissioned. So it hasn't been connected to a Matter network just yet. So we're going to go and do that now in the next video. So the next thing we're going to do is build our first MCP app. So we're going to use the Model Context Protocol to allow our AI agents to communicate with our Matter devices. You can find more information about this on the Anthropic website, and this has detailed information about how to install your MCP servers and what it does. So in order to make this easier for you, we have I put together a GitHub repo called Matter MCP Server, which you can find on GitHub, and the details will be in the course notes. If you copy the link and go over to our terminal, and we're going to go and clone this repo, and we're going to then cd into this particular repo here, and this has got some starter files that we can see here, in particular the matter mcp server.py. So we're going to look at this one. So I've started off with just some really basic code here, and this is come from the boilerplate code from Anthropic. So we're going to start off by including some libraries here. We have the fast MCP library, which is going to provide our MCP server. I'm going to use the async.io library because it's good practice to go and write all of your MCP tools as asynchronous. We're going to create our MCP server, and the first thing we're going to do is we're going to define a really simple basic tool just to add two numbers, just to get this working. So we have a Python function which takes the two parameters a and b, and it will add a and b together. So it's very important here, I'm highlighting the docstring. So the docstring is really important for a MCP server, for a function, because we're going to use the decorator, the MCP2 decorator, and that will tell the MCP server that this is an MCP tool, and the AI agent will use the docstring in order to know how to call this, and it'll pass this information in. I've also shown you a test harness I have here, and it's useful just to go and run the test first of all. I find that's the best practice. So in a terminal, we're just going to run this just to see if we can get this running and everything is installed correctly. So we just do Python. So we're just going to go into matter mcp server.py, and here you're going to see we have we're going to run this code here. So we're going to run this code just to see that it's all working correctly, and you see that when we add these two numbers here, we add 2 and 3, we are going to get 5. So we know it's all working correctly. Now what we're going to do is we're going to go and comment out the test harness and have this command called mcp run, which will go and run the MCP server for us. So now this MCP server should be ready to go, so we're just going to save this, and now we need to go over onto our Claude desktop config file. Now all of this is described in the README. So if I just go to README here, you can see that we have a JSON file that will be located in one of these locations depending on the operating system that you're using. And in the Claude desktop config file, you need to go and include this JSON, which basically tells Claude desktop where to run these MCP servers. So we're going to just make sure we paste this in here and we save this Claude desktop config, and this will define the MCP server that we're going to use. And of course we need to replace the path, the directory path, with your path to your own repo. So you need to go and make sure you replace that there with the path to where you installed this GitHub repository. So we're going to save this file and just make sure that all the details are correct and they match the Python file that we've created here. So let's go and save that, and now what we're going to do is we're going to go over to run our Claude desktop. So you will have previously installed Claude desktop. If you haven't done that, you should install it for your environment. And what we're going to do is open Claude desktop here, and if you just give it just a couple of seconds for it to find the MCP tools, and what you'll find there is if you go into file and view and developers, you can open the MCP log. That's useful. If you don't see this, you can turn on the developer mode in your settings in Claude desktop. So you'll see over here we have the MCP server, and we just click this to see that we have found the MCP server. So we'll see that we have the Matter MCP server correctly there, and that's correctly installed. And if you just click on this little hammer here, you can actually see the command that we have here. So this is the MCP tool that it's going to use. So let's just check if this works. So just going to say, can you add two numbers. So can we add 2 and 3, please? And as a security precaution, it's going to ask for confirmation that the Claude Desktop can run the MCP tool. So we're just going to allow for this chat here. Just select allow for the chat, and we're seeing here the parameters that it's passing in, and then the result has come out that the sum is 5. So now we know that that's all working. So I find this is the best approach. Get this working at the start with a really simple one. We look in our logs, make sure that everything looks fine. Okay, so next we're going to install the Python Matter server. So the Python Matter server comes from the Open Home Foundation and is available on this particular GitHub repository. It's officially certified as a Matter controller, and it provides a connection over WebSockets to a controller that we can use to speak the Matter protocol to our Matter devices. So what we're going to do is the Matter Python server, the Python Matter server, will communicate from our Matter MCP server using WebSockets, and that would allow us to then instruct the Python Matter server to go and communicate with our Matter devices, and then the Python Matter server will then be able to communicate using the Matter protocol to a range of Matter devices, in this case the Matter virtual device. So there's plenty of documentation on the website there. So what I'm going to do is I'm going to show you how to install this. So first of all, I've already cloned this and it's in this folder now, and the first thing we need to do is, as part of the installation, you will have created a virtual environment to install all your Python requirements. So it's very important that we start off by activating the virtual environment, which I'm going to do now. And then once we have the virtual environment activated, we'll just go over to the repo and see the command we use to run the Python Matter server. So we just go down here. If you just copy this line here, and this will run the Python Matter server in debug mode. So this is up and running now. It's downloading a lot of the certificates that it needs, and once this gets going, it's going to be sitting there waiting with a WebSocket that we can connect to from our Matter MCP server. Okay, so I'm going to restart my Matter virtual device, and again I'm going to configure it as a door lock. So select door lock in the device type, and let's give it the name Pod Bay Door Lock, and let's create this Matter virtual device. Okay, so you can see initially the state is locked and it's showing that the device is not commissioned. Now what we need to do is we need to commission this. There's another component of the Python Matter server which is useful. It's called a dashboard, which is a node-based web application which allows us to see the devices that are connected to our Matter fabric. So what we're going to do is I'm just going to cd into the dashboard. Again, we just need to source our virtual environment here to be sure, and I'll cd into our dashboard, and I'm just going to run this script called script/develop, and you'll find this over on the documentation on the repo. So this will start up our node application, and it's going to be waiting for a connection. Now all this documentation is over on the website here, and you can see here in the dashboard we show you how to install this. So just follow the documentation here to install this. So if we go and click on this and open the dashboard, you see we have a number of nodes already. I've got a number of nodes on my Matter network. I have a smart plug and I have a smart home hub, which is a Zigbee hub. And you can also use this to commission a device. So we're going to commission a new device onto the Matter network. So what we need to do is we need to push in a JSON structure into the WebSocket, and we need to send that in, and then we'll get a response out. So we have to include the WebSockets, so we're going to be using a WebSockets library here, and this is the structure of the message we're going to be sending in, and this is to commission on the network using a pin setup code of 2020-2021, and the WebSocket is running on 127.0.0.1. So we're going to run this code now, and that will go and commission our node onto the network, because the Matter virtual device is now waiting to be commissioned. So as you can see here, back on our repo, there's a load of information about all the WebSocket commands here. So if you look on the WebSocket documentation, the Python Matter server has got a lot of commands we can send in. Commission on the network, opening commissioning windows, we can get nodes, get information on nodes, we can get an information on a particular node, we can start listening, we can write attributes, read attributes, or we can send a command. So we're going to be using all of these as part of our MCP tools in later on. So first of all, what I'm going to do is I'm going to run this Python script commission on network, and again we're going to initially just activate the virtual environment so we have all of the required pip libraries installed, and we're going to just run the Python commission on network, and this will go and commission our virtual Matter device onto the Matter fabric. So if we just have a look at that, was not commissioned, and just going to run this script now, and you see we got information back here, and if we look at our Matter virtual device, it'll show us that the device is now commissioned. So this will enable us now to go over to our dashboard, and on our dashboard we should see we have 3 nodes now, and node number 11 is the new one that's been put on, and this is our door lock. Okay, you can see here our door lock, an endpoint 1 and endpoint 0, and it's a door lock. And inside an endpoint 1 you can see we have a cluster called door lock, and we have the lock state. So I'm going to put the Matter virtual device and the dashboard side by side here, and I'll show you as I change the door lock state, we'll look at it getting reflected in the dashboard. You can see the lock state has just gone to 2, put it back to locked, and the lock state has gone to 1 there. So we can see there that as we change the Matter virtual device, it's being reflected on our dashboard. So I'm going to open my Matter MCP server in Visual Studio Code, and let's walk through the code here. So again, at the top I'm going to go and import all of the libraries. The new ones here are the chip libraries that we need for controlling Matter devices. Again, we have the fast MCP, but we have a new function called send WebSocket command. So this is going to be where we send information over the WebSocket. And you can see here we have MCP tools. We have one for get nodes. We have one for get a node. And what I'm doing right now is I noticed a little bit of a problem before where the response that comes back from the WebSocket, if it's too large, it can be problematic to send back as a response to the MCP tool. So what I'm going to do is I'm just going to shorten this, just take the first 300 characters of this response. So that'll allow us just to test, see if we get it working, and then I'll clean that up later on. Just we're going to get this working now. Okay, so we have the MCP tool for get nodes, we have the MCP tool for get node, and you notice here the message is the same as what's in the documentation here on the Python Matter server GitHub repository. So we've created MCP tools for all of these individual messages that we're going to send in, and this is all provided in the GitHub repository, and all of these provided there. But the important point to note is that each MCP tool, we have to be really clear on the doc string as to what's actually happening and what parameters we have to pass in. So we're expecting the agent to go and call them correctly. Okay, so down at the bottom of our code we have the main function which is going to call the run on the MCP tools, and we have all the individual MCP tools ready to go here. And like I showed you, all of those MCP tools relate to the messages that we can send into the Python Matter server. So you see here under the device command here, we're going to send in a command name for a particular node ID and cluster ID. Now it's important that we know the command names, and this can be a bit tricky for This can be tricky for our AI agents to know the command names. So I've got a way to show that later on. So we're going to open up Claude Desktop again. Just wait for it to load. And again, we're going to put the side by side. We're going to have the Matter virtual device, and we have these tools now. So all the MCP tools are in here, and we have the device and the node ID will come in. So all of the MCP tool will be called, and the agent will have to pass in the node ID, the cluster ID, and the command. And it's important that we put a very clear doc string in here for the MCP tools. So we're going to put in all the arguments, just make sure that it's clear. And if we do this correctly, then the AI agent will know from the LLM how to call it directly. So that's very important. And if you are having problems with the MCP tools, it is generally, I think the doc string you use to describe them really does go and act as a prompt towards the LLM in order for it to use the tools correctly. So you need to make sure and spend extra time making sure these are correct. So this seems to be working for me now, so I'm just going to save that one. And what I'm going to do is I'm going to go back to okay, so I'm just going to go back. I had node 11 and endpoint 1, and the door lock there is on cluster 257, and the lock state is 2. So cluster 257 is going to be the cluster we're dealing with here. So if we go back to Claude here, and we have our virtual matter device, and if we look at the tools should be there. So can you use the device command to send a command to my door lock? And let's be really specific with what we have here. So if I tell it that the node ID is 11 and the endpoint is 1 and the cluster ID is 257. So I'm going to be really specific at the moment just to help it find this. And the command we want to send in here, let's say the command name is unlock door. So let's go and send that and see what happens. So just go and make sure this is correct. So it's going to be able to send unlock door. Okay, it's actually slightly different the way we spelled unlock door, so just make sure we have that correct. Let's go back there and make sure we say unlock door. Okay, so I'm going to hit, so lock door, it's already locked, so we're going to say lock door. So we're going to send this, it's going to call the MCP tool here. So it's detected that with node 11 and endpoint ID 1 and cluster ID 257 and the command named lock door. And you see it successfully ran that and it successfully locked the door. So what we can do now is, let's try and do something similar. Can we unlock the door? Now it should know from the context history there, we'll say, can you unlock the pod bay door? So we should see, I'll help you unlock the pod bay door, and it's sending that command unlock, and it looks like it's being successful on our Matter virtual device. That's been correct. And let's try now, can you lock the pod bay door? So it should know the node ID and the endpoint ID at this point, so it should just be able to send that straight away. And let's have a look at the Matter virtual device. It's sending the right command in there, and it's gone to lock. So if you already have your Matter devices already set up on a Matter network using a smart home hub, I'm going to show you how you can open a commissioning window for this. Again, what we're going to do is restart our Matter virtual device. We're going to remove the configuration and we're going to restart our Matter virtual device. So again, what we're going to do is we're going to go and change this to be the door lock. And we're going to give it the name pod bay door lock. Okay, so we've created that device now. Now what I'm doing is I'm showing you my Android phone, which is connected to Google Home. So I'm just going to open up this now. So this is Google Home running on my Android phone. So what I'm going to do is I'm going to select the devices. I'm going to open up the QR code on our Matter virtual device, and the device is not commissioned at the moment, so I'm going to open up the QR code. Then over on my device, my mobile device, I'm going to go and choose device, choose that it's a Matter enabled device. It's going to open up a QR code scanner here on the camera, so I'm just going to open that up now. So I'm going to use the camera on the device to go and scan the QR code. and that's detected it now. And now I'm just going to agree to connect this to my Google Home. And now it says getting ready for setup, and said I'm ready, and now it's going to search for the device, and it's going to connect to the device, and then it's going to register it on my smart home network using Google Home as a controller, and you can see the device is now commissioned. So I'm just going to add this to a group of devices called the virtual devices, and I'm just going to call it the door lock. Okay, I'm just going to call it the door lock and go next. I'm just going to set this up in Google Home, and now you can see it's showing up on my Google Home. If I go into it now, and if I press the hold to lock, I need to press it, and you can see the state of the lock has changed to unlock. And if I go and press it again, the state of the lock will be changed to locked. So this is all working perfectly fine. So I can go and inside in the settings, if I go to link Matter apps and services, and then I link the apps and services here, I have a pairing code. If I take that pairing code now, I can now use that pairing code to go and configure this Matter device onto my Python Matter server. So this will work for you if you already have a device. So using our Python Matter server dashboard, I'm going to commission the existing device. I'm going to go and put in this code now. So the code is 0154. Now we just put the dashes in as well, 351-0146. And I'm going to commission this now. And what's going to happen now is this has been commissioned as node 12. And you'll see here that it shows up as an extra node, node 12. So what's interesting here about this, it's now being commissioned onto two Matter fabrics, you can see here. And this device here now, if I go and I show the state of it, if I go into node 12 here and look at endpoint 1 and look at the door lock cluster and look at the lock state, currently the lock state is 1, and that's for locked. Now if I go and I change on my Google Home, I go and hold to lock it, and you'll see it's now changed to state 2. So this is just demonstrating multi-admin, which is a very powerful feature. So what this means is that if you have existing devices that are already connected on your network, you can use the multi-admin feature by opening a commissioning window and connecting that device to the Python Matter server, so you can control all your existing devices with your AI. So you can see here, this is already connected. It's connected to two fabrics. One is Google Home, and what I'm going to do is going to remove it from the Python Matter server, and you see it's been removed here. And you'll see here if I go link Matter apps, it's now only connected to one fabric, which is the Google Home. So let's go back onto the device here, and if you look at your device here, it's again, even though we've disconnected the Python Matter server, we can still go and control this device using our Google Home. So we've only removed it from the Python Matter server fabric. Now if I change the state on the door lock, that state gets updated in Google Home as well. This is a very powerful feature that you should be aware of. So this opens up huge capabilities. We're going to set this up on Claude Code. So assuming you have Claude Code installed, we're going to use the Claude MCP add, which is going to open up a guided way to set up our MCP servers. So the first thing, we're going to give it a server name. So we're going to call it the Matter MCP server. And what we're going to do is set this up for global. And then we need to put in the command here. So remember, the command we're using is the UV, which you will have previously installed to get the MCP server working on Claude Desktop. So we're going to look at the Claude Desktop configuration. We're going to use this to set up our configuration for Claude Code. So we're going to go and first of all put in the -- dictionary, and then we're going to put in the path. Now this will be the path to your particular repo, so just make sure you put in your repo path here. Then we're going to use the next part of the command, which is to run. So we're going to use run, and then we're going to put the name of the Python file, which is the matter MCP server.py, and this is the code we have. We used this earlier on Claude Desktop, so we're going to use this now for Claude Code. So we're going to put that in there. We don't have any environment variables, and just do confirm. So now this has already been added. So we just do finish, and then we do Claude MCP list, and that will show us that we actually have the matter MCP server is working there. So if we go and restart Claude Code there, so we do Claude MCP list, we can see it there. If we start Claude Code, we can now go and try to interact with our MCP tools. So I can ask what nodes are on my matter network, and what it's going to do is it's going to detect that I have a MCP tool called get nodes. So that's going to return the details. So I'm going to use that one. And this has returned some JSON string there, and now currently Claude Code is looking at that, and then it pulls out indeed that I've got 3 matter devices on my network. So I have a smart plug, a smart hub, and a door lock, which is on node 13. So what I'm going to ask is what commands are available on node ID 13. So it's going to go and query this particular node, so get node, and it's going to go and get the information back. So a lot of information has come back here. It's just going to go through that, and it's going to look at some of the information here. So it shows that I have a number of clusters here and a number of commands. Now these are not exactly right though, and this is interesting because it's assumed from looking at the JSON, it's tried to infer what are the commands, and it shows that there's a toggle on off on cluster 257, but this is actually a door lock. So it's actually the lock and unlock commands we should be using there. So I'm just going to ask it, I think node 13 is a door lock, can you check what commands are on cluster 257? This is the door lock. So let's be really specific on node 13. So let's see what it does. It's going to again use the MCP tool to get information, and it's going to read the attribute, which are the attribute, and it's going to read this attributes where are the supported commands. So again, it shows a little bit better. We have lock door, unlock door, toggle door. So as you can see, it's had to try a few times to try and get that, and we can see that it is correct. But we're going to carry on anyway and show that we can actually control this. So I'm going to put these side by side, Claude Code on one side and the matter virtual device on the other. So I'm going to ask it, can it tell whether it's locked or unlocked? So we're going to read the attribute, and it's read the attribute of the cluster, and it shows that it's currently locked. So we can see that it is. So we're going to say, can we unlock the door, please? So again, it's going to go and send the device command now. So we've got the device command, and it's going to send this now. Let's look, and now it's changed to unlocked there. Okay, so it's unlocked there, changed. Now, we're going to try something else now. So what we're going to do now is we're going to go see if we can remember from the context and just say, please lock the door, and it should just remember that it's on the device command here. So we're going to go and send the device command with all the details that are there, and the door should be locked successfully. And then we can ask it to check if it is locked, and we can show that it's going to read the attribute for the right cluster, and it shows that it is locked. You may have noticed in the last piece that the Claude Code had difficulty getting the right commands initially. So what we're going to do is we're going to help the AI agent to understand the commands by using the XML data that's covered in these files that are on the Connected Home over IP repository. So we have XML files here. So what I've done is I've created a MCP tool which can go and tell us the commands that are available on each particular cluster. Now this is called the data model tool, and it's a simple Python script that I've created which will go and parse the XML and return a set of commands for each cluster ID. and it's useful as well. So what we're going to do is we're just going to add this here like we did before. So we're going to go and do what we're going to do is we're going to add this MCP server to the Claude Code. So first of all, we're going to call this the Matter Data Model MCP. So we're just going to copy this from the Claude desktop JSON. And again, we're going to use this. We'll install this just locally for the moment in the local project. We're going to use UV as the command because that's the command we're using to run our MCP server, just like in the Claude desktop configuration. And what we're going to do is put the parameters in here now. So we're going to point at the directory. So take all these parameters from our Claude desktop configuration. So directory, let's put in, I'll just go back. Okay, directory, and then put in your directory for your repo. So wherever this repo that you download, whatever you called it, the location, you should put it, the path there. We want to put the run command. And then we want to run the script called the Matter Data Model MCP. Now this script is available in the Matter MCP server GitHub repository. Now there's no environment variables, and we just confirm and that we've added this. So that's fine. So we can just enter now and edit. And what we can do is just go and check Claude MCP list. Okay, so what we'll do is we'll just go and confirm that we have added this MCP server. So now we have two MCP servers, one for the MCP, the Matter MCP server, and one for the data model. So we're going to go into Claude Code, and if we just go and do /MCP, we can show the MCP servers and they're all connected, so we're working well there. So we're going to use this now to go see if we can go and check, get information from this data model cluster. So you remember the last time when we were using the AI agent to go and lock the door, it found it hard to discover what were the commands. So this is why we provided this particular data model MCP. So the AI agent should know to go and use this to find out what commands are on particular clusters. So what it's going to do here, it's going to go and identify that it has a data model MCP to get the cluster commands. So it's going to pass in the door lock. And then all of these commands get sent back out because this is being parsed by our MCP server. And it indeed shows us that we have the locked door and unlocked door. So this really will help our MCP server to go and, get it right first time when it's trying to engage with the sending commands. So we're going to just check this now, see if we can unlock the door, please. And it should know straight away just to send so it's going to get the nodes, because it has to find out what is the door lock. It doesn't know what node it's on, so it's looking for all the nodes first of all. Then it's going to go, it thinks it's on node 13, so it's going to go and get the details of node 13. And here what it does is it then is told it's found the right node, and now it's going to send the device command using cluster 257, and it's using the unlock. So now it's changed the state to unlocked, so that worked successfully there. So if you're in Claude Code and you want to find out more information about coding Matter devices and Matter software, then over on my website called Matter Coder, I have provided a lot of code labs. So I've actually gone and made a MCP server which allows Claude Code to get information about that. So this is called the Matter Coder search. So I'm going to add the Matter Coder search in. So we're going to use UV again. And again, we're going to go and take the directory parameter, add that in, and we're going to add the path in for where the Matter MCP server is located, and you're going to change this to your path. So I'm going to add this in, and we're going to do run. And the particular command, the Python script, is called Matter Coder search, and what this is going to do is allow us to search the Matter Coder website for specific code labs. So when this is ready, we're going to finish this and just make sure that it's all added. So again, what we'll do is just go and check, and we should have 3 MCP servers, and we've added the Matter Coder search. So we're going to go into Claude, and what we're going to do is now going to ask Claude to find some information. So again, just check that the servers are working. We have all 3 servers working there. And I'm going to ask you, tell me how I can, so let's say, tell it the steps to install Matter on macOS. Okay, so it's looking at this, and it's probably just checking its own trained data. So using its trained data, it has like 4 steps there. So I know I've got much more detail over on my website, Matter Coder. So if we ask the Claude Code to get more details and to get it actually from Matter Coder. So it's looking here, and it's going to search over on the Matter Coder website, and it's going to ask to go and do this MCP tool. Now it's pulled back all of the articles that I've written there, and it's gone and highlighted one that we can click on here, and we can click and look at that. So we'll just do another example here. Can you read that link? Now unfortunately it's not able to read this link here because it's for security reasons it's not able to read this link. So let's go and do another quick check. Let's ask it, how can I bind a switch to a light on the ESP32? And I'll say check Matter Coder. So again, it's going to go and call the MCP tool here. It's going to ask us for permission, and it's returned a number of different articles that are over there. And then here it's turned this lab. So if I click on this, and it will bring up the particular code lab here that shows exactly how to do this. Now this is really powerful stuff, because if you're a developer of Matter Code, I have code labs that are specific for stuff you might want to do. So let's try, let's say, how can I install the Matter SDK? It's going to call it the Connected Home over IP. It was previously called Chip, on, say, Ubuntu. And I know I have another article for that. So I'll say check with Matter Coder. So let's have a check. So again, it'll do another search here, and we'll ask it, do we want to do it? And say yes. It's pulled back these articles here. And here what it's done is it's actually done a quick summary of it there, and if I click on that, you'll see here we bring us into the particular article that we need. So hopefully that'll be helpful for you. Now you have everything. You have a controller, the MCP server that can control your Matter devices, but now you also have one that you can get information from.
We're all talking about the arrival of AI agents, but you know what's even more exciting? Getting them to control real-world devices using Matter, the new smart home standard. At mattercoder.com, we built a hub packed with code labs and courses to train developers on Matter and AI. And with the Model Context Protocol, you can plug this knowledge directly into AI models. If this sounds like your thing, like and subscribe, and let's dive in.